Okay, this is a lesson on solving quadratic equations. We're going to review a method we've learned previously, which is by factoring, and we're going to learn a new method which is called the square root property. Again, quadratic equations, just so we can make sure we know what that means. That means you're going to have the highest value of the term, the highest value of the variable is going to be 2. So for example, if I have x squared plus 3x plus 2 equals 0. That would be an example of a quadratic equation because of this 2. And a quadratic equation can be as simple as x squared equals 100 and solve that equation. So these first equations I'm going to show you, this one is already a quadratic equation that's already been factored or in factored form, so we can apply our old friend the zero products property. So we're going to solve by really the zero products property. Let me just kind of add that by factoring and the zero products property. Again, that's the old method. So we're just going to set each of these items that's being multiplied here equal to 0, since one of them has to equal 0. So I'll go 2x minus 5 equals 0, or 3x plus 6 equals 0. I'll add 5 to each side, and I'll get 2x equals 5 divided by 2. X equals 5 halves, or 3x equals negative 6 divided by 3, or x equals negative 2. As always, I got to check these, make sure I haven't made any arithmetic errors, so I'll say 2 times 5 halves minus 5 times 3 times 5 halves plus 6, and so that'll be 5 minus 5 after I cancel these 2's out, times, and that's 7.5 plus 6, so that's 0 times 13.5 equals 0, and that's true. By the way, I'm asking myself that. So 0 does equal 0. And then the other one, that's going to be 3 times, I'm sorry, not 3, it's going to be 2 times negative 2 minus 5 times 3 times negative 2 plus 6 does all that equals 0. Well, this is going to be negative 4 minus 5, so that's negative 9 times, and that's going to be negative 6 plus 6, so that's 0. So 0 equals 0, so they both check and both are valid solutions. All right, the next one we have is 9x squared minus 3x equals 0. Again, I'm going to solve this by factoring. I've got a common factor in both terms of 3x. That'll leave me with 3x minus 1 equals 0. And I have these two factors multiplied together equals 0, so 3x equals 0, or 3x minus 1 equals 0. So if I divide by 3, one of my possible solutions is 0. And my other possible solution, after I do a little apply my properties of equality, is 1/3. So x is 1/3, or x equals 0. And I'm going to check over here. I'm going to check in my original equation. Let's check 0 first. 9 times 0 squared minus 3 times 0 Does that equal 0? Well, that's 0 equals 0. That's pretty clear. Everything equals 0 on that left side. And then I go 9 times 1/3 squared minus 3 times 1/3. And it does that equal 0? Well, that's 9 times 1/9, so that's going to be 1, and 3 times 1/3 is 1, so 1 minus 1, 0 equals 0, and that checks out. And so that validates those two solutions. Okay, so next we're going to solve x squared minus 5x equals negative 6. So what I first want to do with this one is get the 6 on the other side. So I'm going to add 6 there. And that will give me x squared minus 5x plus 6 equals 0. Then I can factor this. Recall how to factor this. Since I have a lead coefficient of 1, I've got factors of positive 6 that sum to negative 5. That would be x minus 3 times x minus 2 equals 0. I can apply the zero products property and get x minus 3 equals 0, or x minus 2 equals 0. I'm going to add 3 to both sides, and I got x equals 3, or x equals 2. I'm going to check those over here. So let's check those. If I have 3 squared minus 5x, does that equal, not 5x, it's going to be 5 times 3. Does that equal negative 3? So, no, sorry, negative 6, looking down below. Negative 6, so that's going to be 9 minus 15, and that does indeed equal negative 6. So 3 is confirmed. I'll try 2. I go 2 squared minus 5 times 2. Does that equal negative 6? And that's 4 minus 10 equals negative 6. Negative 6 equals negative 6. And so that confirms both solutions. I'll circle those. Alright, so this problem down below here, I'm going to have 4x squared minus 5 equals negative x. Well, I want to get the negative x to the other side, so I'm going to add x, and I'll have 4x squared plus x minus 5 equals 0. I've got to factor this. So I've got some possibility, a little harder one to factor here. So I just got to play around with this a bit. So I could have combinations of, I could have combinations with 4x and x and 2x and 2x. What I'm pretty sure about is I'm not going to have anything with a 5 showing up right here with either of these combinations. So I'm thinking if I put a 1 here and a 5 there, that's not going to work. So I think it's going to be something with the 4 and the 4x and the x. So I'm going to try the minus 1 and the plus 5. Okay, that looks like it. So I'm going to try 4x plus 5 and x minus 1. We can see that's the right factoring because that will get us, and again I did that by inspection, 4x squared minus 4x plus 5x, that gets me that 1x, and then 5 times negative 1 gets me that. So this is the right factoring. And I've got 4x plus 5 equals 0, or x minus 1 equals 0. Subtract 5, and I've got 4x equals negative 5, divide by 4, and so let me slide this up a little bit. So I'll check now with x equals 5/4. So I'll go 4 times so my original equation is 4 times, so it's negative 5/4 squared minus 5. Does that equal negative x? And negative x is, I should plug in the opposite of 5/4, negative 5/4. So that's a question mark. So that's going to be, you can use your calculators for this if you want to keep this from being so much busy work. So that's going to be 4 times 25/16 minus 5. Does that equal positive 5/4? So this is going to be 4. So that's 25/4 minus, and so that's 25/4 minus 20/4, and there's your 5/4. So 5/4 equals 5/4. The other check should be a little easier to work with. So I've got 4 times 1 squared, and that's going to be minus 5. Does that equal negative 1? So that's going to be 4 minus 5, and that does equal negative 1. Negative 1 equals negative 1, so that checks, this checks, so those two solutions are confirmed. Alright, so now let's talk about this new property we're learning to help us solve quadratic equations. This is by the square root property. So the square root property says very simply that if I have x squared equals c, then x has to equal either the square root of c or x equals the negative square root of c. And we usually write that as, now that's actually writing two solutions, but so this is kind of your property in its generic sense. So if I have x squared equals c, then x has to equal the root c or negative root c. So we'll see that when we do our check in this next one, how this will work out nicely. So for x squared equals 49, that means that x equals the positive or negative square root of 49. And since that's a perfect square, I'll say x has to equal either positive 7 or negative 7. I can check that very easily. I say 7 squared, does that equal 49? 49 equals 49. And then I want to square negative 7 and ask if that equals 49. And it does. So that validates both of these solutions. Remember, I'm writing two solutions in one right there. This next one I have x squared equals 20. And so I'm going to say x has to either equal the positive or negative square root of 20. I want to simplify that radical and call that positive or negative. Remember how we'll do this? 4 times 5. So x will equal plus or minus 2 root 5. So I can check this one. Does 2 root 5 squared equal 20? Well, I square the 2, square the root 5, so that's 4 times 5, so 20 equals 20. Same thing happens if I square the negative 2 root 5. That also will mean 20 equals 20. So those are two good solutions. So slide up here. Let's do these two next. I've got 6x squared equals 24. So what I'm going to first do here is actually divide both sides by 6. Just make this a little easier to work with. And I've got x squared equals 4. That means by the square root property that x equals the plus or minus square root of 4, positive or negative square root of 4, so x equals positive or negative 2. And I'll move that up a second so I can show my check. So my check is going to be, if I have 6 times 2 squared, does that equal 24? Well, that's 6 times 4, or 24 equals 24. And then I'll go 6 times negative 2 squared. Well, that's also equal to 24 because negative 2 squared equals 4, so 6 times 4 is 24. So that confirms those. So let's look at 4x squared minus 64 equals 0. Now we could do this one by factoring, but we're going to do it by the square root property. So I'm going to get this 64 to the other side. And that'll make it 4x squared equals 64. I'm going to get the x squared alone by dividing by 4. And I get x squared equals 16. So x equals the positive or negative square root of 16. So x equals positive or negative 4. I'm going to check it by plugging in 4 for x squared. So I'll get 4 times 4 squared minus 64. Does that equal 0? Well, that's 64 minus 64, so everything checks out there. And I'll go 4 times negative 4 squared minus 64. Write that a little better. And that also is 64 minus 64 equals 0. 0 equals 0. So I will call my answer positive and negative 4. Alright, now getting a little more challenging. I've got x plus 2. I've got x plus 2, the quantity squared equals 81. So just like if I had x squared equals 81, x would equal positive or negative square root of 81. Now I can just say x plus 2 equals the positive or negative square root of 81. So remember, if I had x squared equals 81, I would have said that x equals the positive or negative square root of 81. But now since I have an expression, I can say the expression x plus 2 equals the positive or negative square root of 81. I'm just going to go ahead, since 81 is a perfect square, I'm going to say positive or negative 9. Then I'm going to subtract 2. Now what this means is that x equals positive 9 minus 2, which is 7, or it means negative 9 minus 2, which equals negative 11. So I can check both of those. 7 plus 2, the quantity squared, does that equal 81? Well, that's 9 squared equals 81. 81 equals 81. Then I'm going to plug in negative 11. And I'm going to ask myself, does negative 11 plus 2, the quantity squared, equal 81? Well, that's negative 9 squared. And that does equal 81 also. So that confirms my two solutions of 7 and negative 11. Alright, let's do this one next. Similar kind of problem. One thing I want to do here, though, is I want to get this 24 to the other side first. I'm going to add 24. And now have x plus 3, the quantity squared, equals 24. Well, if the quantity x plus 3 squared equals 24, that means x plus 3 has to equal the positive or negative square root of, based on the square root of a square root property. And so let me simplify that radical a little bit. So remember, that's got a 4 in it. So I'm going to say x plus 3 equals positive or negative 2 root 6. I'm going to subtract 3, and it's customary in this situation to write this x equals, we're going to put the negative first, and again this is expressing two different solutions. So one of my solutions is negative 3 plus 2 root 6, and I can't add these, they're non-like terms, or negative 3 minus 2 root 6. So I can check both of those, and probably a good idea to use your calculator here so you don't have too much busy work. So I'm going to substitute negative 3 plus 2 root 6, and then plus 3, the quantity squared, minus 24, and does that equal 0? It's not, you can use your calculator for this, but it's not too bad because you end up getting the 3 and the negative 3 make 0, so you end up with 2 root 6 squared minus 24. Does that equal 0? Well, 2 squared is 4, root 6 squared is 6, so that's 24 minus 24, and that does equal 0. We'll do the other one right here. And then I'm going to say negative 3 minus 2 root 6 plus 3 minus 24. That's the original equation. And again, the 3 and the negative 3 cancel, so I get, not cancel, but are opposites. So I get negative 2 root 6, all that. And by the way, that was squared. Minus 24, does that equal 0? Well, negative 2 squared is 4, root 6 squared is 6, so that's again 24 minus 24 equals 0, so 0 equals 0. So that's confirmed, and those two solutions are confirmed. All right, this next one. On this next one, I want you to recognize that this is what we call a trinomial square. So it factors, this factors to a binomial squared. So again, this factoring becomes very important. So this factors, I'm not going to subtract the 18 from both sides because I'm going to notice that this is a trinomial square. And since we know how to solve by the square root property, we're just going to go right from here without getting the 18 to the other side. We wouldn't be able to do it anyways because it would be unfactorable because you're going to end up with some irrational solutions here. So if x minus 2, the quantity squared, equals 18, then that means that x minus 2 equals the positive or negative square root of 18. Well, the positive or negative square root of 18 can be simplified. That's got a 9 in it, so that'd be 3 root 2. Then I'm going to add 2 to both sides. And again, it's customary to put the standalone number first. 2 plus or minus 3 root 2. So my check becomes pretty complicated here. I would tell you to use your calculator. So when I square, I'm first going to square 2 plus 3 root 2 minus 4 times 2 plus 3 root 2 plus 4. And does all that equal 18? I think you'll see that it does. And checking your calculator, then, and by the way, I forgot to square that. And then I'm going to do it with the negative version, 2 minus 3 root 2 squared minus 4 times 2 minus 3 root 2 plus 4. Does that all equal 18? And I think when you plug that in, you'll see that it does. And that's those are your two solutions, okay? Now, let's look at one more thing to get there. Okay. Alright, so let's slide this up. Now I have 6 times the quantity x squared plus 7 equals 7 times the quantity x squared plus 1. I'm going to go ahead and distribute here and make that 6x squared plus 42 equals 7x squared plus 7. I am going to subtract 6x squared from 6x squared and 7x squared, and I'll have 42 equals x squared plus 7. So then I'm going to subtract 7, and I'll get x squared equals 35. So x would equal the positive or negative square root of 35, and you can't simplify that. So we're going to go ahead and check that. So 6 times root 35, actually I don't need that. I will with the negative, but I don't need a, so that's going to be root 35 squared plus 7. Does that equal 7 times root 35 squared plus 1? Well, root 35 squared is 35 plus 7 equals 7 times root, so root 35 squared is 35. So you end up with 6 times 42, and we need to know if that equals 7 times 36. And it certainly appears they do. That's going to be 12 and 1, so they both equal 252. So that works. We're going to check the negative solution. So we've got 6 times, and this is where I'm going to use parentheses again, negative root 35 squared plus 7. Does that equal 7 times negative root 35 squared plus 1? And you're going to end up getting the same result here of 35 plus 7 equals 7 times 35 plus 1. So we're going to get that same outcome of 252 on each side. And so we'll circle those as our two solutions. Alright, this last one we can solve any way here. So I'm going to try factoring with this one. I think, so let me pause it and play around and get the correct factoring here. So I played around with this real quick and zeroed on this as the factoring. I'd get 10x squared plus 5x minus 4x minus 2. So I'm going to solve this by factoring. 5x minus 2 equals 0, or 2x plus 1 equals 0. So add 2, and I'll get x equals 2/5. And I'll subtract 1, divide by 2, negative 1/2. And so then I'll check both of these real quick. I got 10 times 2/5 squared plus 2/5 minus 2. Does that all equal 0? Welcome to use your calculator on that, but I'm fairly sure those are right. So let's go with that, but check it with your calculator. And then I'd go 10 times negative 1/2 squared plus 1/2. I'm sorry, plus negative 1/2 minus 2. Does that equal 0? I think you'll find that also works when you check it with your calculator. So those are good solutions. This next one is just a little more abstract because it's just got a lot of variables. Last problem here. So if I have x plus b squared equals 16c squared, so I'm going to say that means x plus b has to equal, I won't require you to check this one, plus or minus the square root of 16c squared. So I'm going to then subtract b from, now let's go ahead and figure out what that is since that's a perfect square. So I've got x plus b equals positive or negative 4c. So we're going to subtract b, and we'll call our solution here negative b plus or minus 4c. I won't make you check that one. It's a little bit much. So that's the end of the lesson.